first off, I'd like to thank everyone here that is taking part in today's Automation Tips webinar that is centered around building ready-to-deploy code-free automation sequences and user interfaces. So we are really focusing a bit more on more complex automation, as well as building custom UIs. So my name is Jeremy, and I'm the education leader at Vention. My role is essentially to educate users, such as yourselves, on how to use the machine builder platform, which is the design portion, and machine logic, which is the automation programming portion of Vention's manufacturing automation platform that we'll be focusing on a bit more today. So with that, I'll actually jump right into the content that we will be seeing throughout the rest of the webinar. Over here, let's switch over here. So the agenda for today, we have 4 main goals. So the first is to just showcase the quick recap of what we showcased in the first machine logic webinar, is how to configure a machine. From there, just a brief explanation of a simple path tracing program using basic move commands that, again, were previously covered. But if you do have any questions, if we are covering something new for those that are here for the first time, feel free to ask questions throughout. And then from there, we're getting into the main portion of the webinar, which is creating a more complex path tracing application using variables and loops. And finally, building a custom UI for this application that we will be creating. Throughout the webinar, there are a few different ways that you can interact. The first being through the Q&A section in the Zoom platform. Also, you can actually chat with other participants in the chat section. And finally, at the end of the webinar, we will open up the mics of all the participants. You'll notice they are all muted for the moment, but you will be able to open your mic to ask any questions to myself at the end. We do also have my colleague Alfred here on the line that is monitoring both the Q&A and the chat section. So if I do miss anything, he might actually try to answer the questions directly throughout the webinar itself. Finally, one thing to note is that the webinar is being recorded and will be sent out afterwards through a link. With that, we can actually jump directly into the content that we will be seeing and switching over to the design. So today, the design that we'll be focusing on is a glue deposition application. So real briefly, over here, what we have is a 3-axis machine. Zooming in, we have the first axis over here that goes left to right. We'll call that one the x-axis. The y-axis is the dual-driven timing belt. And finally, the z-axis is a rack and pinion setup. One thing to note for this session, we'll be mostly focusing around the 2-axis system, just using the x and the y. But for 3-axis systems, they do come in play when you're doing something a bit more complex, say pick and place. In our case, since we are doing glue deposition, this is mostly done in a 2-axis plane. So with that, I can actually jump into the rest of the webinar, which is actually the machine logic portion. So one thing to note when trying to access machine logic, you will have to have a machine motion controller in your design to open up the machine logic tab up here. In our case, it's under the cabinet over here, which does make the machine logic tab accessible. So with that, I'll click it to open it up, and this will land us on the configuration tab, which is the first portion that I like to showcase. So already this machine has been pre-configured just to save a little bit of time, but I'll run through how easy it is to do. All you have to do is click on the Add Actuator button in the bottom left corner, and then from there, it does populate this drive window over here. From there, you select from the drop-down window the actuator you'd like to configure, and it actually automatically populates both the motor as well as the end stop sensor ports over here. So the way it works is it scans through your design and notices any sensors or motors that are attached to that actuator. If you do have a vertical actuator and do have a brake installed, it will notify this with a checkbox under the brake installed. So you'll see here, if I hover over that, it highlights the brake on the z-axis over here. So again, very brief overview of how to configure your machine. If you'd like to see a bit more in depth, we can maybe cover that at the end of the webinar or see in a previous webinar how this is done. From there, I'm actually going to be jumping into the visual sequence to showcase what a basic program in machine logic looks like. So again, machine logic is designed to be built using code-free sequences, with the main sequence being where you build and assemble your program, and the child sequences over here on the left, essentially being the functions that you call within your main program. In our case, we do have one pre-built, but I'll run through it just to give you an idea of what it is. So the 2 child sequences that we have are the homing sequence. I'll actually do a top view over here of the design to get a better view. So the top view, you'll notice on the machine itself is a square square rectangle over here, pardon me, a white square. And what this is the poster board that would be depositing glue around. So machine, when we want to move it to home, move to the bottom left corner over here. First, move the x-axis over to the left, and then the y-axis down to the bottom. From there, we will try to trace a square path around it. So essentially, we'll trace a path around the edge of the poster board. To go to the main sequence is where you actually build the program. In our case, this has already been done, but just to showcase how easy it is to build a program, I can delete the 2 actions over here, go to Add Command, and select Add Execution. What this command does is it calls those child sequences that we've already created. In our case, I'm going to do it in series, and then select from the drop-down menu the sequences that you've already created. First, we're going to home, and then follow a square path. So in our case, let's get a top view over here, and then press play. So you'll see what it does, it highlights in green the action being accomplished on screen at that time. So first you have the home sequence moving to the left at the bottom, then the square path is following the 4 actions of tracing around the outer edge. You notice after it's done, it does jump back to the design's resting state, and this is normal for machine logic behavior. From here, we're actually jumping into the bit more complex side, and actually what the main portion of this webinar is around is creating a path that is more useful for glue deposition, and then building UI off of that. So if there are any questions about what was seen here, again, just a brief recap of what was already shown. You can feel free to ask them now. If not, I'll move on to the PowerPoint to showcase what we'll be looking at. All right, perfect. So opening this back up. So from here, the goal is to create a more useful path for glue deposition. So in our case, right now, what we just did is we had the machine trace a path around the outer edge of our poster board. Realistically, to get proper coverage, you might want to have a path that covers the center portion as well. In our case, our goal is to create a spiral path to accomplish this. So looking at this, what we have to do is get the machine to trace a path first along the bottom outer edge, the right outer edge, and then as you start going to complete the other edges, to create a smaller and smaller square pattern as we get towards the center. So this can be accomplished using machine logic, and I'll be showing how to do this. So to do this, there will be a few extra steps that will be needed. First, we'll be introducing variables, and then later on using loops as well. But some of the information that we'll need to keep in mind is first the points over here. So you have a point 1, a point 2 with coordinates 0, 0, and then 630, 630. And then finally the spacing. So the spacing will be essentially the spacing between each line that we are depositing as we travel along our path. So I'll go back to our machine logic sequence that we have over here and build this out. So one of the great things about machine logic is you don't actually have to delete any of the previous work that you've done to start creating new ones. You can simply go down to the bottom over here, click on add sequence to create a new child sequence. So that's what I'll be doing, and I'll be naming this one spiral path. And pressing enter to confirm. So the first half of this is going to be a very similar program to the square path over here by first completing the 2 initial motions. So again, moving to the right and then moving up. So that I can go to add command and click on add motion twice. From here, I can select the actuators I like to do to complete this motion, first being the X, second, I'm going to select the Y, and then the type of motion. So in this case, I'm going to move to a specific position. So here is where the variables will come into play. Again, I can simply type out the position that I'm looking to have, such as the square path, I had 630. But if I want to be able to create that spiral path, I'm going to have to create a variable that is editable or modifiable throughout my program. And in order to do that, I'm going to go over to the variable section that you see on the left over here. So clicking on variables brings you to this window over here. You have 2 separate variables that you can create. And in short, essentially what a variable is for machine logic is a globally referenceable value that can be called throughout your program at any point. So the first type of variables are essentially numeric variables. Again, just simple numbers that can be modified or changed throughout the program. And the second are inputs as variables, which are variables that can be modified via inputs, such as our digital I/O module or our push button module. For today, we will be focusing a bit more on just the variables or the standard variables, but there is a bit more information on the inputs as variables on our resource section on the webpage if you are curious about that as well. So in this case, I'm going to build out those 3 variables that we had seen earlier in the PowerPoint presentation. So it's easy as simply clicking add variable, and since I need 3 of them, I'll create 3 of them. This one I can rename. One thing to note when creating them is you cannot have spaces or special characters. So to get around spaces, you can use underscores, but you cannot have special characters such as ampersand signs, pound, and etc. Second one I'm going to create is 0.2. And then finally, the spacing. So as we saw again earlier, 0.1 will have an initial value of 0. 0.2 will have a value of 630. And our spacing that we're looking to have, we'll give it a value of 75. So that I can go back to my spiral path to actually build out my program. So from here, again, like I said earlier, you can't simply type in the value that you're looking to have. But in my case, I'm going to be using a variable. The way you actually input the variable is you simply start typing out the name, and it will fill in or give you a drop-down menu option of the ones that match what you've already typed in. Again, if you have continued to type out 0.2, it will only give me the 0.2 option. But in this case, since I typed in point, it will give both of them. So again, I'm gonna have my X and Y axis travel to point 2. And at this point, this is where it gets a bit more complicated. So once I travel to my corner, I actually want to change my variable so my actuator doesn't travel all the way to the end, but stops a little bit short at each corner. In order to do this, I need to update my variable. The way this is done is by going to the add command section in the bottom left corner, and then clicking on set variable. Again, I'm gonna be changing both of them, so I'll add 2 of those commands. And again, say I actually added it a little bit too early, a little bit too late. The way machine logic works is you can actually drag and drop commands to different areas within your program. Now to actually edit the variable, it's very simple. You have 3 different options. The first is to edit it from an expression. Second, from a device, again, being an input and output device. And third, from an actuator position. In our case, we're going to be doing it from a mathematical expression. Then we'll select from the drop-down menu the variable that you would like to modify. In our case, we're going to be modifying point 2 and point 1, and then showcase how we would like to change it. In our case, what we'd like to do is have it stop a little bit short. And then what happens with the variable expression over here is it replaces the current value of the variable once this command is executed. So in our case, we're going to take the current value of point 2 and subtract spacing from it. So at this point, if we're starting with 630 millimeters and subtract the 75, we will end at 555. Now we're going to do the inverse for point 1. We're going to start with our current value of point 1, except this time we will add spacing since we are starting from 0. So what will happen is our point 1 will slowly creep towards the center, going from 0 all the way up to the center point, and the point 2 will go from 630 down towards the center point. Now that we've updated the variables, we can build out the rest of the motion of our system. So we'll add 2 more motion commands and have the x-axis and then the y-axis travel to my point 1. Again, the way this will work, it will travel to my newly edited point 1 from this variable set variable expression. So in this one, I'm going to type in point 1 and then point 1. So running through the program that we've created over here, we can see what we've done. So we start off by having our actuator move to the top right corner, modified our variables that we created a little bit earlier so that they no longer travels all the way to the end, and then move to its new point 1 position. So from here, we'll go to the main sequence and see how we can actually build out our program. So again, we're going to leave the homing sequence since this is required or recommended when doing automation sequences, but the second one is the one that we're going to modify. So we can simply change it to the spiral path that we have just created. However, one thing to note is if we play our program from here, it will only execute 1 loop and will not actually continue in this spiral. There are a few different ways to get around this. First, it's possible to add multiple execution commands to have the spiral repeat over and over again. And this will work. However, you will not have a set end position, and you will have to calculate how many times you'll need that command to execute. The other option is the one that we're going to be focusing on, is to bring in a loop command. So all we're doing is deleting this execution command over here and adding a loop command. So loop commands function very similar to other programming languages. Essentially, it causes a child sequence, in our case, to loop or run a set amount of times, or based on a condition. So from here, we have 3 different conditions that you can select from. The first being to run forever. Again, this is a possibility, but at that point, your simulation will never stop. The second option is to run based on a count number of a set count. Again, this is similar to having by adding multiple different execution commands, but a little bit cleaner by having it all done in one. Again, by having count, you do not have a set termination point, and sometimes you might have it the glue deposition not run far enough or run too far. The final one that we'll be using is based on a condition. So in our case, a while condition. The way the while loop functions is that as long as this condition is true, it will continue to execute our desired sequence. The one that we'll be using as our condition is to check to make sure that our point 2 is always larger than our point 1. Again, this can be used inversely by having our point 1 is always smaller than point 2. Then from there, once it double checks this, it will run our spiral path. So the way this works, it will run the first sequence, do a full lap essentially around the board, check to see that our variables still satisfy this condition. And if they do, we'll continue to loop around. So that I've essentially created a functional program to trace the spiral path that I showed earlier. To see it work, all I have to do is press play. So again, since we're starting in the center of the board, we're just going to home and then run the spiral path over here. So if you do have any questions, now would be a great time to ask as we watch the simulation run. Notice over here, it updated the variable and no longer travels all the way to the edge. One great thing, obviously, this is a slightly larger program. So rather than having it run the entire time all the way to the center, you can actually stop it if you'd like to edit it as you go along. So in our case, I'll let it run one more time to see the commands as they loop through over here. Again, highlighting the action that is being complete. Then going back to my main sequence and simply clicking stop if I'd like to terminate a little bit earlier. Again, you can let it run if need be. So from here, that showcased how easy it is to use variables and loop commands to create a slightly more functional and complex automation sequence that can be done using our standard commands, but does make it a little bit cleaner to do. From here, we'll be going into the second half of the webinar, which is actually creating a custom user interface for this application over here. So if you notice on the top of Machine Logic, there are 3 different tabs you can select from. The first being the configuration that we saw at the beginning, second being the visual sequence that you saw us edit through, and the third one being the UI builder. So this is what the UI builder looks like. The way the UI builder works is very similar to our standard machine logic in that it's been designed to be very easy to use for all operators. It simply functions by dragging and dropping the widgets that you see at the bottom over here into the location in the center to build out your UI. So in our case, there will be a few things that we will need to do prior to actually building out the UI, but I'll touch on those in a second. The first thing that I'd like to do is build the basics of it. The first is going to be the information console. So the way it works, again, I'll select the information console from the bottom over here and drag it into the section up top. From there, I can then resize my information console or any of the other widgets to the appropriate size if need be. So for my case, I'm going to resize it to be a little bit shorter to leave room for some of the other commands and buttons that I will be using in the user interface. So from here, I have the information console set, but right now there will be no information being output. To do this, I'll actually have to go back to my visual sequence and edit my program a little bit so that there will be some information output as I run my program. So for that, I'll go back to my visual sequence and add 2 separate commands that are useful for the user interface. The first one is going to be a add wait command. So what the add wait command does is essentially waits for a set action before moving on to the next command in your main sequence. Again, these can be used in your child sequences, but for us, we're going to keep it in the main sequence. The option that I'm looking for is to wait for a set event. This will come into play a little bit later when I go to add a button to my UI builder. One thing to note is that when you are adding a button a bit later, is the topic and the message do have to match the button in the UI builder. Again, this will make a bit more sense when I add it. In my case, I'm going to simply call it start and leave the message blank. The topic itself, you can name it something that is a bit more descriptive for yourself so you know what action is being called upon when it is being used. From here, I'll go down to the bottom and add one more command that will be useful for the information console that we added, and this will be the add message. What the add message does is it actually sends a message at this point out to the information console in the user interface that you have created. At the moment, we only have one, so we only have one information console to select from, but you do have 3 different levels of message that you can choose. First being info, warning, and error. If I go back to the UI builder, it will the message will pop up with one of these 3 widgets here prior to the message to showcase what type of message it is. In our case, I'm going to be leaving it as an information one and type out the message that I would like it to output once my application is complete, which will be glue deposition complete. So the way this works is the program will run through, and once it's terminated, will output this message to my information console. So I'll go back to the UI builder and build out the rest of my user interface. You'll notice over here, it's no longer accessible. This is because it's been changed to the play mode. If you'd like to edit again, all you have to do is go to the right and click on edit mode. So from here, I'll be adding 4 new widgets. The first one is going to be a variable input. The reason why I'm going to be adding a variable input is right now with my variables, I essentially can only deposit glue on one set size of poster. If I'd like my operators to be able to do different size posters, I need them to be able to edit the variables while in operation. So I'll take the variable input widget and drag it into my UI over here. From here, I can rename the button itself. So in this case, I'd like to edit the poster size. So I will aptly name it poster size, and then choose the variable that this variable input will be editing during its operation. So again, it's all done in the drop-down menus. If I do have any extra variables, this is where they will also be found. So in this case, the 0.2 actually sets the poster size of my glue deposition machine. So I'll select 0.2. And then here you have the ways that the operator can actually input. You're going to have them select either number input, which gives them essentially free range to input any number from 0 to X. In our case, I'll set the default value as 450. Again, you can then set a max or a min depending on your application. In my case, I'll set a minimum of 100 and a maximum of 630, since you see we cannot go past that point on this poster board over here. With that, I click done, and it'll change the name as well as the default value that you see over here. We'll resize it to the center, and then do a second variable input that will be used to change or edit the spacing of my glue deposition. So again, I'll rename it spacing to be very easy to reference during operation. In this case, I'm going to link it to the spacing variable. In this case, to make sure that operators aren't spacing the glue too far, I can actually set it by predefined values. So with this, I can then input a few different numbers, such as 50, 75, 100, and let's do the last one of 125. With this, once I press done, I'll resize it. And to show you what that looks like, if I go over to play mode, you notice over here, I can change the value itself by, say, typing in 500. Or in the spacing one, I only have a drop-down menu. So in this one, I cannot input my own number if need be. So going back to the edit mode, the one thing that we're really missing is the button to actually start the sequence itself. So I'll add the button, name it aptly start. And this is where the topic comes into play that you saw earlier. So again, with that wait for command, this is where you saw the topic and the message. And this is the button actually sends a command to that message, to that command specifically. In my case, since I've already created it, I can select it from the drop-down menu and press start. And since there was no message, this does not have a drop-down menu as well. I can change the color if I'd like, then click done to confirm and resize it. The final widget that I'll be using over here is simply a label. Again, this is really just a text widget that allows you to input any, say, instructions for your UI as for any operators. In my case, I'm just going to call this glue deposition, and then change it to a header text to be a little bit more visible. Resize that out to this bottom. And you'll see there are a few different widgets that I did not use, such as variable display, as well as digital input display. These really just showcase what the status of the variables are at that current point in time. But in my case, if I'm happy with my UI that I've built over here, I can click on play mode to actually use it. So going back to my visual sequence, I'll just run through it one more time to see how it works. So it'll wait for my event, which will be the start button, home, run the loop, and then output the message over here saying that the glue deposition is complete. So I'll go back to my UI builder, press play to actually initialize the machine logic program, and then select the poster size. In my case, I'll select one that's slightly smaller and a slightly larger spacing just to have it run a little bit quicker. Once I press start, it will then run based on this UI that I've created. So as this runs, I can open the floor to any questions if you do have any. But one thing to know, I will be showcasing one more example that does showcase how powerful the UI builder is. You're not limited to simply creating path following applications like this. So notice as it gets to the end, it will output that glue deposition is complete. So from here, I'm actually going to drag in one extra example to showcase how UI builder can be used. So right here, we just have a simple linear actuator that allows it to move back and forth along its available travel. Opening up the UI builder, I have two different UIs over here. The first one, what allows me to do, or what I've done over here, is create a simple jogger. So I can select, say, a value that I'd like to jog to, and press jog. And what this will do is normally it does send it to home. Oh, I actually have to press run program, pardon me. This will send it to home. And then by pressing jog, I can actually jog the actuator by that increment. The way I've set it up is that it outputs the amount that I've jogged it and gives me my current position. So this is the variable output. If I change it to say 35, it'll say that I've moved by 35 and then add that new position. From here, if I go to the other UI, just to give a final example, press play to initialize machine logic, we'll send it to home. And this allows me to then send it to 3 or 4 different positions along its available travel. I can click on position 2 to send to that predefined value. If I'd like to change it, I can simply press, say, 505, send it to that position, or send it back to my starting position. Again, with UI Builder, it's basically limited only by what you can create in your visual sequence itself.